Let's focus on the cloud for, let's say, the next hour. Sepp and I will talk around the architecture of DX Cloud, mainly for those who are not working yet with our cloud solution. And then in a half an hour, we bring Adrian from the dev team onto the stage to talk about the cloud cockpit. But first, as mentioned, we talk about the architecture and who we are. So we have Sebastian Klingberg, our lead DevOps solution architect, and myself, Lucas. I'm the head of cloud services at Magnolia. So what are we going to cover today is really the tech stack of our DX Cloud solution. Then we want to dive into our standard architecture. Sepp will then dive more into the details of the technology we are using. And then over the past few years, our architecture really evolved. We have different solutions now based on our standard architecture, and he will dive more into that in a bit. But first, let's have a look at our tech stack of our cloud solution. So if we go from top to bottom, so if you're already familiar with our cloud setup, you know our CDN solution out of the box, we work with Fastly CDN, is really at the center and the core of our solution. Without the CDN, our product wouldn't have as much success as we have with it today, because it observes most of the traffic that is coming to our platform. Then right below the CDN, we have the load balancer based on Nginx Ingress, which does the load balancing to the publics. We will see that on a later slide. We have at least 2 publics on our solution. So the load balancer makes sure that none of those publics are overwhelmed with traffic. Then on the bottom, we have the CI/CD pipelines. So if you are opting in for our GitLab, then we provide the CI/CD pipelines. If you bring your own pipeline provider, then we provide blueprints. So we really want to make sure that whatever project you do on our cloud solution, you are following the best practices and the blueprints. And then on the bottom, it's really the hosting, reliable and secure. It's easy to scale, and we rely on AWS, Azure, GCP, and in Switzerland we have Mironet as our Swiss hosting provider. So we base everything on container, Kubernetes, and our infrastructure as software on cloud, which then Sebastian will dive more into it. And all those layers are basically monitored. We have an alerting system in place. We have the cockpit where you can go into the cockpit and see all the logs, see all the metrics. Adrian will then talk about that a bit later. So if we look at the standard architecture, so if we go back to day one of our past solution, this is with what we have started approximately 4 years ago. So if we shift our attention to the right-hand side, this is our central cluster. This has been replicated now in 3 different regions. So it's in the US, in EMEA, on Mironet, and in APAC in Singapore, so that the latency to our customers, performance to our customers, especially in the cockpit and on the monitoring stack, is as performant as possible. So on the central services side, this is a multi-tenant infrastructure, obviously highly secured, so no data will be shown to other tenants in that central services cluster. So what we have in there is basically the authentication based on Keycloak. Our customers can bring whatever authentication solution they have in place. We pull it into a Keycloak and make sure that the authentication works perfectly. And on the right-hand side, we have our monitoring stack. So we rely on Thanos, Prometheus, Loki, and Grafana, and we have an alerting manager in place. We see the cockpit API, so all those metrics and logs are being consumed by our cloud cockpit. So if something is off with your project, you go into the cockpit and you can start analyzing what might be off with the website of your customers. Then on the left-hand side, so this is really single tenant based. This is basically per customer. So we have in the standard setup, we have 2 clusters. We have the non-production cluster where all the development happens. So we have usually integration, UAT, dev environments. So we try to replicate the production on the non-production cluster. So we have a UAT with author and 2 publics. And if everything is well on UAT, we push to the pipelines to production. So we have the production cluster with what I already mentioned, at least 2 public, so that's the default. If you need more, we can scale up, obviously, and add more resources to the clusters. We deploy to any major region, as already mentioned, AWS, Azure, GCP, and Mironet here in Basel. So we really can cover worldwide scenarios. Then below the clusters, we work with Rancher for the orchestration. So you probably are all familiar with Rancher. And then we have the pipelines to really push the code through the environments up to production as well. And with that, I'm handing over to Sebastian for the architecture components.
Yep, thank you, Lucas. So yeah, I will spend some words on the architecture components and also maybe you understand why we decided to architecture ways the way that they are today. I know that maybe some of that are maybe basics and you're already familiar with that, but I still want to spend some words actually also on a bit of the fundamentals. And I'd like to start in the top right corner with Kubernetes clusters. And especially as I know, like some of you in this room also migrated from older Magnolia environments like the Cloud Free, for example. Where we had then basically a set of VMs. In the end, it was cloud VMs, where Magnolia was running as a monolith. And from the beginning, actually, from the past, we said, hey, we want to run on Kubernetes. Not only because there's managed Kubernetes on basically every big known cloud vendor, so we always wanted to achieve cloud or to be cloud agnostic. So that was one thing, but also with all the feature set that comes with Kubernetes. Yeah, it's not only the trend that, and of course, is there for a reason with container-based workloads, but also like all the extensions around it. Especially what we also try to enhance more and more usage of operators and stuff like that. But nevertheless, the start was to really like using the Helm package that we have. And with that, I think there was a very early start for the whole PaaS and Cloud DX journey. The next thing is actually Nginx load balancer, or Ingress Nginx it's actually called. So, of course, only one of the critical components, but I think especially in our case, where we mostly talk about really some web presence in a way, we need a central point to communicate to the outer world. And what I want to mention here is that we also said, hey, we want to find the most common denominator actually in a lot of things. And this is why we have also this one here in place to ensure that we have layer 4, layer 3 load balancer. Maybe that's also like if I'm using too much terminology, especially the Kubernetes one can be very confusing. Please don't hesitate or hesitate a bit and wait for the Q&A and maybe I can clear that out then. So yeah, but you know, network load balancer, so the thing on the IP level directly goes to the cluster. That's why we decided to do it this way. Another very critical component, I mean, now it's called here Fastly CDN, I would say a CDN in general. While we may, of course, benefit from all their self-healing Kubernetes, having load balancers, all running in cloud, scaling up, down is not an issue. However, to really cover a big amount of load on these clusters, we need a CDN actually to cover. We need some strong caching. We need also a web application firewall, all those kind of things to also mitigate DDoS and stuff like that. And that's why we also, from the beginning, were looking for CDN. So Fastly was our choice here. What we then can also provide you here is with Fastly, we have automation basically for certificate uploads, configuring the domains of Fastly automatically. So That was also very important to us. Of course, you can also, as Lucas also said, use your own CDN. The work is a bit more on your side, but it's still, of course, possible because we designed it this way. Yes, in the end, the Ingress Engine X is just a backend way to enter the cluster, and whatever we do in front is then another story, but usually a CDN should be in place. Going down to Rancher, I said we want to be cloud agnostic, but still we need some central point to communicate with the Kubernetes clusters. And maybe we also want to have, we'll spend a few words later on that, we want to have multiple cloud vendors even on there. We could have done all the stuff purely on Kubernetes. What Rancher brings in here is actually a central point of authentication, which is very handy because I said, regardless of what vendor we use, if we use Azure, if we use GCP, if we use AWS or the local hosters, it's always the same way to communicate with the cluster. Plus, we can also take use of the RBAC model. All the authentication is centralized, basically, and we can even leverage and also their so-called project schema to ensure that you only see what you should see, and also on our side, of course, to protect our clusters in a way. Not that we don't trust you, but I'm just saying. CI/CD pipeline, that's of course the next thing, because if you want to build Magnolia, of course, you also want to have a modern way of building your application and deploying it. And we said that the CI/CD pipeline in that way, so at least for the moment, the right way to build these images and push it to a cluster, and always have the option to roll back to do enhancement. It also allows you to use different projects. For example, light modules very often are in a different project than the core Magnolia, for example. And this is also what we, of course, here as a strong blueprint provide with GitLab. But also here you can use whatever you want to use. Maybe also here what comes in with Kubernetes as well. So we have with Ranch and all that, we have still the kubeconfig access, which is also still highly demanded. We slowly also pushing to be a bit more tokenless, with an agent-based authentication for the CI/CD pipelines. But those kind of things, as you can see, we're improving on all of these steps here, all of these points. And central services in the end is what Lucas explained. So, of course, we also collect logs, we collect metrics, we do all the kind of things. We also have the IDP, which you, of course, can integrate yourself. So you have a more or less seamless SSO experience here. Plus, of course, the cockpit where Adrian will talk, I guess, after our talk, a bit at least. Good. Few words on architectural evolution. So Lucas presented you the standard offering. That was also the very start point of the PaaS or Cloud DX. But very early, we also saw that we needed some sort of let's say, an entry-level PaaS. And nevertheless, production ready, it's working. But it's just a smaller setup. One cluster where we have, for example, here, as you can see, a dev and a prod environment on the same cluster. How do we achieve this? It's actually also following best practices on Kubernetes, calling a dedicated node. So there's a thing called labels, which you can put in Kubernetes node saying, hey, this is, for example, my dedicated prod label in combination with a so-called taint. So the taint is basically a restriction for a Kubernetes scheduler. Let's say, hey, only run workload here, which has the toleration for example, dedicated prod. Otherwise, please do not, or at least try not to refer no schedule, that's the term, to use them. And as you could think of, we are fairly limited in that way that, of course, we started, for example, with the 3-node standards as we had it. Back then, our default was 4 CPUs, 16 gigs RAM, so forth. And then we quickly saw, hey, even with 2 environments, with this dedication, with the dedicated nodes, it's just not too much to run all the environments. If you follow the best practices that we have also on our documentation, it says a public should have roughly 10 gigs if it runs in production, often maybe 10 to 12. So, and then if you do the math, 16 gigs, not working that out. That's why we also said we use for the PaaS basic 4 nodes from the start, and that's also what you see here. So we have here our 3 nodes for the prod environment where we use this dedication that I explained earlier, plus we have let's say a buffer node for a dev environment, right? Yeah. What we also found out when we do this, while we still want to have some sort of flexibility, you know, things can go wrong, nodes can go down, have issues. We still may want to allow that prod may use the dev nodes, right? Because, I don't know, something's broken, whatever. Which is working. But the thing is also, and this is what we have it here, we have it in the same AV zone. If you may know, like, it should not be stateless, but of course we still need stateful applications in Magnolia. We still have a database, we still maybe have our light modules, we still have our JCR index build up during startup, so we do not want to do this action again when we have to restart on another node or whatever. So we need volumes. And volumes on cloud providers can be a very tricky thing. If they are in so they're in the same region, in Frankfurt, for example, but there are 3 different availability zones. And it's not so easy to basically copy one volume from one AV zone to another. It's good for resilience. It's unlikely that the whole region goes down, of course. And even if, then we may have other issues, but zones maybe have some issues, and that's also why in the standard offering we use those 3 availability zones per default. But for Fast Basic, as said, to still have this flexibility, we then also decided, hey, we put all of them into the same AV zone, so in case something breaks down, the prod at least is able to also spin up in a dev and whatever, or we in general have more flexibility. One last word to the basic cluster, because we also have these requests quite often. Can we add more nodes? Of course we can. That's also a cool thing with Kubernetes, with the managed cloud services. But also here again, if it's about, for example, an additional node for Solo, which you anyway share between dev and the prod, it's fine, right? But even then, if you do more, I mean, we have already 4. Imagine the next one, and we are on 5. And the past standard is already a dev cluster dedicated and a dedicated prod. So in the end, we are very close to a standard offering. So that's just what I was about to say. So it's really like this, as a production ready, healthy, good, stable setup, which you can use, especially also, I think, if you have more static content on your website, when you also maybe have not that high amount of front end runtime or code required. Yes. So the other end is actually what we call now the premium setup. So this is in the end is like the standard setup plus what we call here now a satellite. And a satellite cluster, as you can think of, like, will then run in another region than the main cluster. That could have different use cases. The first one, which of course comes in, if we think again, like a region may have an issue, a zone's having issues, we have a completely independent zone. Maybe even on a different cloud vendor, which is in that way independent that even like all the things go down. For example, in Frankfurt, the US side is still up and running. So resilience is one thing. That's also why we have topped up the availability guarantee to a 99.9% per default. And as said, you can even like mix them up with different zones. We have, for example, I think it's fair to say also, our corporate website is running, for example, here on AWS in EMEA, and we have a Azure representatives in Australia with a satellite approach. So those kind of things are working. Yeah, the rest is basically the same. We have a dev cluster. Maybe how these clusters are communicating. So when we started, we used the service mesh, and in particular, we used a feature of a service mesh. It's called Lickerd. That's the solution. You may know it, like amongst Istio and Auxilium or so. It's quite known. And it's very simple. And the cool thing was not only that it is simple in terms of like setting up and maintaining. It's also cool because Lickerd is this thing called Service Mirror. And it worked out. It works well. But what we found also is that, like with large publications, due to this simplicity, it may come to the points in the way, or has some issues in the way that Magnolia is publishing bit transactions, basically. So if you have bit applications, you most likely then run into filling up the connection pool of Lickerd. Then auto recovers and everything will work again, but that's an issue. And then also thanks to our partners at MirrorNet, we together integrated a new, it's kind of a similar approach, basically. We're free to say that. So we use MTLS, mutual TLS connection between those clusters to do the application still. But that said, less overhead on and data and stuff. Plus, what we also do is to ensure, and that's of course the important thing, that at least like activation key pairs and all those kind of things are equal, or at least let's say in an organized way with the primary cluster together. Yes, and I think that's it actually for me. Thank you.
All right, thanks a lot, guys. Am I on? Can you hear me? So do we have any questions? Questions? Ah. Who was it? Thanks.
Hello. About it. Yeah. So as we were talking about load balancer, mentioned that it is handling the traffic at L3 and L4 layers. But then why we are using ingress, which usually look into the application data and decide to route the traffic based on that. If it was needed, maybe we could have used directly the network load balancers specifically.
I may repeat the question. So as you ask why we are using the network load balancer, not application, or?
No, vice versa. Why we are using the ingress, the Nginx, and not the specific network load balancers. If the traffic, it will always check for L3 and L4 layers and not L7 as well.
Yeah, well, in the end, it is the network load balancer that we are using. That's what I'm saying. Sorry if I was not clear maybe at that point. So we really use the L3 IP-based network load balancer, not the application-based one. One reason is actually for that because I had the example with Fastly with the CDN. So, you know, for example, if you on your cluster use a Let's Encrypt certificate, let's say like this, you resolve the certificate locally in the cluster and you want to upload it to Fastly. If the network load balancer would not be in that position, how should the certificate come to the cluster? And then also how can we then pick it up with our operators and configure it somewhere? Yeah. So that's why it has to be, or that's also why we decided to have this network load balancer, not the application-based one. We're more flexible, let's say, more fundamental. And also, again, not cloud restricted. We're very agnostic because in the end, like it's IP based. So
Maybe it is more versatile in that case. It is more versatile.
Exactly. Thank you.
Thanks. Any other questions? Last call, questions. Yeah, I actually had one question. What about there's like these front-end pods that you can have for running things. Were those sort of in the public, or is that some different dimension?
That's a good point, actually. Yeah. So front-end pods are actually just run or workload which runs next to Magnolia, actually. And that's also one good feature of Kubernetes in the way that it is. I also explained like CI/CD. So front-end pods could be another project to which you deploy to the cluster in the same way as you deploy Magnolia, maybe even via Helm, you pack it yourself, I don't know. And then it runs just next to it, and you can still use all the functionalities. So we can use the redirects that we have, the configuration of the Fastly side, and so on and so forth. So front-end is definitely there. And that's also, like, I think, the flexibility that we have in this platform, actually. Yeah.
Great, thanks. Hey, thanks so much, Seb and Lucas, for the presentation.